Hi, thanks for joining us. My name is Álex Campos, and I work as a solution engineer for Cloudera. And today we're going to talk about low-code real-time analytics. So the idea is to understand how you can use open source components to develop an end-to-end real-time data pipeline. Hope you enjoy the session, and feel free to send your questions, and our team can address them. Okay. So let's cover the agenda. First, we're going to talk about the Cloudera data flow platform and its components. Then we deep dive a little bit in the use case we're going to develop during the session that is related to predictive maintenance. And then we going to develop the use case, the data pipeline during the session. Okay, so let's start. Cloudera data flow, but before talk about the components of the platform, I want to talk about a little bit about the challenge that companies are facing when work with real-time data. First one, the data ingestion. Collect the data from different sources and high volume of the stream data. So those components or those devices, they have different protocols from different vendors. So it's really hard to collect the data from those sources. The other one is get insights in real time. Not only in just the data in real time, that is something that we can do, but also trigger real time actions on top of that data. And the last one is visibility. Not only the operational aspects of the data and the components, but also related to secure and govern the entire data throughout the pipeline. So those challenges, the idea is to understand how we can, overcome those issues with Cloudera data platform. So the components of the platform, the first one is related to the components that allow us to ingest data from different sources. It can be components like NIFI, NIFI, that we allow us, to collect data from IoT devices, trucks, trains, machinery, and any kind of device that is generate, data. The other one is how we can perform some kind of analytics and process the data in real time. Okay, components like Apache Flink, Spark, and libraries that complement Kafka allow us to run some kind of low latency event processing and real-time and get real-time insights on top of the data. And to transport the data at scale, we have Apache Kafka, okay, that allow us to manage topics and all the different agents or applications that are consuming and produce data on those topics. Also, components related to the management of the Kafka clusters. SMM and Replication Manager allow us to do that. Okay, so the platform, we are going to use the different components of the platform depend of the complexity of the use case where we want to implement. Okay, so in terms of the architecture, we start to add those components in different steps, or let's say in different layers of our architecture. The first one is to collect the data. We can use NIFI and NIFI to do that. Okay, so we can install a NIFI agent and those devices and collect the data. Then the data is sent to a Kafka broker or Kafka cluster that allow us to centralize all those different data, real-time data sources, okay? With NIFI, we can reach the data, we can distribute the data, we can do some kind of data preparation on top of that data. And then the data goes to different, let's say, applications. It can be a real-time, application that we consume a machine model, or can be some kind of aggregations on top of the data. And then for further analysis, we usually store the data at rest. It can be object storage in the cloud, can be a data lake, a more traditional way, or also some kind of operational data layer like HBase in Kudu for fast data, okay? It is important to understand that when we collect the data, we are, let's say, building a complete data lifecycle. Okay, so once we ingest the data in real time or batch, let's say, way, we can enrich the data, use some kind of data engineering process that allow us to, let's say, use the data for a machine learning model to train some kind of machine learning model. Also, to data discovery or business intelligence application more related to a data warehouse, and also some kind of applications that has higher concurrency in terms of reading and writing data. Okay, something related to operational database. This complete data lifecycle should be secure. We need to track all the lineage of data in each steps, and also register the metadata we have in each steps. Okay. It is important to also understand that this platform can be deployed in two flavors. Okay, it can be used, or let's say deployed in a public cloud. It's a platform as a service. Okay, so you can choose your cloud vendor to deploy the platform in the cloud. And also we have the, let's say, the more traditional way to deploy the platform for on-premises factors. It can be a bare metal or virtual, let's say, virtual machines. And also you can use container cluster to deploy those components in, let's say, on top of Kubernetes as well. Okay, so we have two options. Okay, and you usually choose the one that is, depending on the use case we are going to develop. Okay, so now it's time to understand the use case we're going to develop. It is related to predictive maintenance. So the idea is to understand how we can use the different components. This type of use case, it is implemented in different industries like, mining, transportation, also in bank as well, or for IT infrastructure. So we have different, let's say, use case for this type of initiatives. Okay, so to understand the drivers, the idea is to increase the operation efficiency. So to have our machineries or our trucks, maybe in a mining processing plant, working on 100%. Okay, and also decrease unplanned outage. Okay, so avoid any kind of problem that we have our, it can let's say cause some time of downtime in our infrastructure. So those are the two drives that we need to focus when developing this type of use case. Regarding the architecture, this IoT architecture is composed of two main, let's say, environments. The edge environment that is outside of our, let's say, data center or our cloud environment, and also the Cloudera data platform environment, or where we are going to, perform all the analytics and store the data for analysis. Okay, so first we collected the data from those sensors. Those sensors are sent the data to a local Mosquito broker. With NIFI, we collected the data and send the data to our data center. Okay, so the data will land in a NIFI cluster. Once the data is in NIFI, we send, or let's say we publish the data to Kafka to centralize all the different sources. With NIFI, again, we consume the data. We score the data in real time using machine learning model exposed as a real time REST API. Sorry, and then we store the data for further analysis. Okay, and with Hue and Impala, we can perform queries on top of the data. And also that we have the data enriched, we can publish the data to a new Kafka topic and use Flink. We can run some kind of aggregations on top of that real-time data. Okay, so we are going to navigate throughout of those steps. So the idea is to understand how those components will be integrated in our pipeline. Okay, so it's time to play. So let's go to the first step. Okay, first step. Now the data is arriving in the local Mosquito broker. We collected the data, is send the data to NIFI cluster. Okay, so the components we are going to see here, the first one is NIFI. NIFI, it's a tool that allows us to distribute the data, do some kind of enrichment on top of the data. You know, you can read from different sources and send the data to all, you know, a variety of destinations. Okay, some cool features we have in NIFI. The first one is data provenance that allow us to track the data, the real-time data in different steps. Okay, also is we can extend the capabilities of NIFI. We can develop our own processors. Okay, and also it is fully secure. Okay, so we make sure that the data is flowing and it is let's say it is under the you know, the standards that the company requires. Okay, the other one is main NIFI that allow us to collect data from edge devices. Okay, so it's some kind of NIFI but with a small footprint that the idea is to, you know, send the data to a centralized infrastructure or platform. And the other one is Headflow manager that allow us to manage and build the applications and deploy those applications on the NIFI agents. Okay, so let's go to the first step. Okay, this is Headflow manager. Okay, that's the interface, and I have this IoT -1 agent that I'm going to deploy an application. Okay, so I have a pre-configured processor. Okay, I explain in NIFI what are the processors, but processors are the boxes that, you know, perform some kind of action. In this case, this one consume data or messages or events from MQTT broker. Okay, so this is the configuration how I connect it to the broker, and you know, the topic filter I have it in this broker. Okay, now I'm going to use RPG or remote process group to send the data to our NIFI cluster. Okay, so I will copy the URL of our NIFI cluster. I will add here. I will also change the transport protocol. Okay, apply, and now I'm able to drag and drop this connection. Okay, from this consume MQTT processor to our RPG. Okay, it asks us for input port ID. Okay, this is the way let's say I segregate the different events that are landing and NIFI. Okay, so this is my input port. Okay, that is already configured. I just need to copy this ID and I paste here, and now I'm able to deploy this this data flow. Okay, so I will publish. I will add some comment. Okay, send data from MQTT broker to NIFI. Okay, something that we can understand later. So it is published. We have the green check here. So it looks like everything is working okay. Now we need to make sure that data is arriving here in NIFI. Okay, so I will connect my input port to this process group. Okay, and I just add this connection. Okay, this process group is the one we are going, you know, the tool we are going to configure later. Okay, so now I can start this input port, and I need to make sure that data is start flowing, is queuing here. Okay, looks like we have data coming here. Okay, so I can list the queue. Okay, and this is one of the data governance capabilities I mentioned before. Okay, so I can go, those are all the events, all the data flows we have, and I can actually see the data, okay, in detail. Okay, so I have the sensor ID, we have the sensor timestamp, TS timestamp, and I have each one of the, let's say, readings of those sensors. Okay, cool. So we can close here. And now our data is coming here. So I'll explain a little bit about the processors, okay? So the processors, as I mentioned before, are the boxes that does or perform any action, okay? So I will explain a little bit. We have almost 300 processors configured in this NIFI cluster. Let's say I can perform actions with HDFS, okay? Delete, fetch, list, put, let's say data in HDFS. I can also work with FTP, okay, if you have some kind of data that is stored in an FTP server, okay. I can also work with Kafka, consume data from Kafka. I can publish or send data to Kafka. I can also work with some kind of protocols like syslog, okay, and others, okay. So the idea of these processors is to, add in our pipeline, depend on the different actions we need to perform in our pipeline, okay. Awesome. So let's go back to the presentation and step 2. Now that we have our data landing in NIFI, we need to understand the schema we are going to work with that data, okay? So for that, we have Schema Register, that is a central repository to store and manage all the data schemas, okay? So instead of hard-coding the schemas, okay, or the data structure in our NIFI flow, we centralize in this Schema Registry, okay? So let's go to Schema Registry, and here I have my schema. The name is sensor reading, okay? And I have the structure we defined for this data, okay? So first one is sensor ID, let's say the device ID, sensor timestamp, and we have also a flag here, is healthy. It can be true or false, okay? The idea is to enrich this flag with our machine learning model. We also have the different readings for the sensor. So we have from 0 to 11, so we have 12 sensors in this device, okay? Awesome. So just to understand, this is our schema that we're going to reuse in our pipeline, okay? Awesome. Step 3, now that we have our data in NIFI, we publish that data to Kafka, okay? So we have 2 components here. The first one is Apache NIFI Registry that allows us, in this case, to manage and store our flows, our applications for NIFI and NIFI, okay? So it is some kind of GitHub repository, but in this case, it is oriented to NIFI and NIFI applications. And Kafka, that is the way you're going to transport the data at scale, real time, and all the benefits we have from this, let's say, methodology to work with Kafka, okay? Let's go back to NIFI. Now, we have more data queuing here, okay? So we are 100% sure that the data is coming. So I will double click in our process group. Process group is the way I group, let's say, or aggregate, let's say, processors that have the same action or functionality, okay? So here's my process group. I will start connect those different processors that are pre-configured, okay? So I have an input port also here that you connect with the other processor. I will start this one, okay? And we can see the data is flowing here, okay? So the data now is queuing inside this process group, okay? We have this processor that is attribute, update attribute, okay? That what we have here is the name of our schema, okay? So the same schema we saw here in the Schema Register. I'm, let's say, set this attribute to get the schema that is already defined, okay? So I will connect here. I will send the success messages. I can also start, okay? So now data is queuing here, okay, because this one stopped. And now I have my processor to publish, or let's say send the data to Kafka. In this case, our Kafka topic is, the name is IoT, okay? So we have everything pre-configured here, okay? And it is important to keep in mind this attribute or this property that is client ID. This is the way you are going to register this producer in the Kafka cluster, okay? So I will connect this one, and I will only send here the failure relationships or events I have, okay? Just in case I have any problem, send the data or publish the data to Kafka, I can send those errors or failures to this, flow, okay? So I will start here. Okay, data is not queuing here. It's not also queuing here. So looks like our data is arriving in our Kafka topic. Okay, so let's go back to the presentation. Step 4. Now that data is going to Kafka, we are going to use a component that is called Stream Messaging Manager. Okay, that allow us to have visibility of our Kafka clusters. Components like brokers, topics, and producers, we can manage in this component, okay? So let's go to SMM, okay? I have here data. I will refresh here the interface, okay? And we have some data arriving, okay? So let's see the messages, okay? So I have I can see some data here, okay? I can browse the data. I can see each one of those messages, okay? So this is the same message we saw in NIFI, okay? It is the same structure. Now we have actually the isFlag attribute already added in our messages, okay? Also, and I can browse all those, each one of those messages I can check, okay, in detail, okay. Let's go back here and let me see if we have more. Yeah, now I have more metrics. Now I can see the producers, okay. This is the same one we registered with the client ID attribute, okay. In this, let's say, producer is producing data in those partitions of this IoT topic, okay? Also, now we have the data in Kafka. Let's go to step 5, and now we are going to consume the data, score the data in real time, and set the data, save, or let's say store the data in a Kudu table, okay? So the components of this step 5 is Cloudera Data Science Workbench, or CDSW. That is a platform that allows the data science team to develop their analytics paper, the pipelines, the train models, and also expose those models as REST APIs. Okay, and the other component is Apache Kudu. That is a storage layer for fast analytics on fast data. So as we are working with IoT data, it is the best candidate to store the data. Okay, so let's go back to NIFI. Now I'm going to the main canvas here, and let's go to the put to Kudu process group, and now I'm going to start to connect all those different processes. Okay, the first one is to the processor to consume the Kafka events. Okay. So I check the configuration. I need to have our topic name here, okay? And this is the way you are going to register this, let's say, consumer as a group ID, and apply the configuration. Now I connect this one with the following processor, and I want to send the success events. And to make sure if I have any problem, I can detect that. I will send the failure messages or events to the funnel. Okay. Now we have the second processor. There is a lookup record processor. This is the one that is configured with the endpoint to consume, let's say, our machine learning model. Okay, so that is the way you're going to score in real time our each one of the reads for the sensors. Okay, so just checking the configuration, it is everything configured. Okay, but we have this key. This is a variable. This is a good practice. All type of parameters or variables we need to avoid to hardcore in the pipeline or in the processors. Use let's say these variables. Okay, so we need to create this variable. So right click variables, and I'm going to add one. So it's cdsw.access.key, and I'm going to put the value. Okay, so I already have here my model key. I will add and I will apply, and NIFI detects that this variable is being used in this processor. Okay, the predict machine. Okay, awesome. So now we can connect with the success to the following one, and I will send any error I can have here. Okay, I will start these two processors just to make sure that everything is working properly. Okay, it is queuing. Now I send data. Now we're scoring our machine learning model in real time. Let's wait. Okay, awesome. So now data is queuing here. Okay. Now that we have the data, now we need to let's say update the attribute, the is healthy attribute that we saw. It is defined in our schema. Okay, that is, let's say we parse the result and add this value to our attribute. Okay, so let's connect the failure, and I will connect here the success, and now I can store the data in Kudu. Okay, so let's check. This is our Kudu configuration. This is the Kudu master. Okay, and I just need to add the table name. Okay, I have this value here, and now I can start. Okay, so for this one, I send any problem I have to the funnel, and now I can start our code. Okay, so let's start this one first. Okay, awesome. Data is not queuing here. Start flowing, and now I can send the data to Kudu. Okay. So awesome. Looks like the data is being stored in Kudu. Okay. So let's continue with the presentation. Now step 6. Now that data is stored in Kudu, we can perform some kind of analysis on top of the data. We have Hue as a workbench. Let's say a user interface to run the queries, and Impala, that is the engineering that we actually process the data. Okay, so let's go to Hue, and I have a query here that I will run. Okay, just check the messages. Okay, so as I can see some data, some of this data. Okay, so I can, let's say, already see the different flags that our machine model it is providing to our data. Okay, to the different readings from the sensors. Okay. Awesome. So this is the first part, and the step 7, sorry, it's bonus track. So the idea is to send the enriched data to our a new Kafka topic, and run some kind of analytics or real-time analytics. So the component we are going to use here is Flink, that allow us to do some kind of aggregation on top of the data. Okay, so let's connect to. Looks like I'm already connect. Okay, you connect to the Flink client. Okay, I am connect. I will create an external table. Okay, this table, just to explain a little bit, the type of connection is Kafka. This is our topic, that is IoT score, and the different options to connect, let's say, the structure of the data. But first, I need to send the data to this new topic. Okay, so I will just connect to here. And I will send, let's say, the success. Okay, and I need to configure some of the options here, and our topic name, that is IoT score. Okay, it's not correct, score. Okay, I will apply, and now I'm able to start this process. Okay, and now the enriched data is start flowing, or let's say published to this topic. Okay. Now I can run some kind of aggregation on top of the data. I will run only one, and I'll explain why it is processing. Okay, so the idea of this query is to run an aggregation of the last 1 minute each 5 seconds. Okay, so the idea is to only filter the unhealthy, or let's say where healthy is equal 0. Okay, and aggregate how many events of this type I have per sensors. Okay, so now I have some kind of aggregation here, and I can see the results. Okay, so we are running. As you can see duplicated events here. This is because the query is a continuous running query. So this is running each 5 seconds. That's why we see the results duplicated. Okay. So awesome. So very simple. We can run. Let's say we can add a new use case to our pipeline. Okay, so just a wrap up, just to finish, we could during this short session implement this let's say data motion architecture, with the different components, how they integrate to build this complete pipeline. Okay, this is the complete picture of the architecture we could deploy, with the different components from the edge environment to our data center. Okay, thanks a lot. If you want to learn more about Cloudera and all the different components, I invite you to register to our weekly demos. Also, we have industry events and all the different, let's say, deep dive presentations we have for real-time machine learning and other components. Okay, thanks a lot. Hope you enjoyed the session, and see you around. Bye bye.